He will present the 10.2.
Thank you. And then after presenting on numerical data, I will present the guideline for presenting numerical data, include 3 parts. First, use the tables and graphs. Second, avoiding misleading graphs. And third, significance test. In this session, we have to know what is table, and what is line plot, and what is column plot. And I will try to present how to use the table and graphs. In this table, it's relatively clear how the update time depends on the number of tuples. And there are 2 algorithms in this table. One is the old algorithm, another one is new algorithm. We can compare the old algorithm with the new one. In order to make more clear on relation between the update time to tuples, we plot the graph that we call line plot. And the line plot shows old algorithm. So we can find the update time increase exponentially with the number of tuples. And in this graph, we add the new algorithm to the line plot, and we add the arrow bar to the 2 algorithms. So the new algorithm appears to be better with a large number of the tuples, but the new algorithm is not better overall. However, which one is better in this graph? We divide this graph into the 2 parts. In the blue area, the old algorithm is better. In the red area, the new algorithm is better. So we can define which algorithm is good. Next part, I will talking about avoiding misleading graphs. What happened on these graphs? What happened? And why we call them misleading graphs? There are 2 parts in this graph. It's blue and red area. In the blue area, we can find the old algorithm is better. And in red area, the new one seems to be better than the old one. So the graph may give the misleading impression that the new algorithm is worse than the old one. This is another example. We can point out which algorithm is better in this graph, and the arrow bar overlaid. It is hard to find real difference in performance between the algorithms. In these graphs, we call a column plot. If you look at carefully, you can find the x-axis start at 0.75. It's in there, not 0. It becomes 0.75. So it may cause the misleading graphs. Today, there are tools available for drawing graphs by automating. However, a drawback is that they can sometimes automatically create misleading graphs. And so, when we use these graphs, we have to be careful and correct any mistake. Next part, we're talking about significance test. If we present a numerical comparison of data from experiment or simulation, we have to apply a test for statistical significance. or we can run the risk of getting incorrect conclusions. In the second 10.3, we were talking about different types of projects in analyzing data. There are 4 methods to analyze data. One, the first, descriptive project. Second, the theory-oriented project. Third, applied project. And then we're talking about a comparison of theory and practice. When we carry out the several objectives, we can achieve the end. So we use the framework to analyze the data. In a described project, we want to categorize and compare previous work within a subject area. So we have to categorize previous work first, and then we select comparison criterion. The third objective, compare the previous work with respect to the comparison criteria. And the next method, we use the theory-oriented project. The aim is extend already existing theory or model. We have to define the detail of the extension first, and then we introduce the extension to the original model. The third objective is compare the original theoretical model with the extended version. The third method is applied projects. We want to gain experience from applying a theoretical model. So we set up a simulator for catching web data, and then we implement the new algorithm in the simulator. The third objective, we test and analyze the new algorithm. Finally, we define the refinements to the design of the algorithm. The last method, a comparison of the theory and practice. We want to construct the theory with correct practice in companies or organizations. So we have to select companies and organizations. Then we try to select the comparison criteria. The third objective is investigate the details of the theory of the particular subject. Then investigate how companies work with the particular subject in practice. Finally, we compare and explain the result. What is a good result? If you can draw clear conclusion with a strong confidence, we can call it a good result. And then there are 4 key points of a good result. First, trust the data. Second, analysis of the data theory. Theory. Anyway, okay. And third, don't introduce any errors. And then we can get clear conclusion with reliable and trustworthy. Thank you for listening.